Hi, we are live. Hello, everyone. Welcome to Be Waste Wise. I am Shweta Dandapani. I am a community builder at Be Waste Wise. Many of you would have seen me in several other webinars. Today, we have Adam Reed, Chief Sustainability and External Affairs Officer of Suez UK, moderating the webinar. He's going to discuss how the waste to energy sector is evolving globally with Demetra Siamis, who's a senior researcher at the Alliance to End Plastic Waste, Jakob Salin, head of sustainability at CISAV, who has discussed waste to energy in the past as well with Adam. And then we have Marco Castaldi, a director of the Waste to Energy Research and Technology Council, United States. Marco is having a bit of a tech issue, which is why his video is not on. So yeah, that's just an introduction to you all. And as usual, please use the Q&A section for your questions. Use chat to add comments, introduce yourselves, etc. Over to you, Adam.
Thanks, Shweta, and welcome everybody. By all means, introduce yourselves. Tell us where you are in the world and what your interests are, whilst we're cracking on with what I think should be a fascinating discussion about the end of energy from waste, or the future of energy from waste, or where does it sit in this kind of global transition to more sustainable resource use. And I think we've got a really brilliant panel today, so I'm quite excited by getting their input. So for those that don't know me, I'm Dr. Adam Reed. I'm the Chief Sustainability Officer and External Affairs Director for Suez, the resource management company here in the UK. And there's nothing better than talking about energy from waste. I've got a podcast later today that I'm recording, and I've got 2 days of conferencing next week on just this topic. Where does the future of this sector lie? And I think when you start looking at the different regions of the world, you start realizing that they're in very different places in terms of transition away from landfill and dump sites to things that are more contained and constrained and better managed. Hence, why many might think that the future of energy from waste is significant. And then those of us in the West are busy working out how do you deliver energy from waste when carbon is the biggest concern facing many of our economies, and therefore, is carbon capture, utilization and storage going to save energy from waste, or actually we're going to see a huge decline in energy from waste technology use and application just because we need to do something better with the plastics? So I think the panel we've got today is a great mix of thinkers and doers when it comes to where are we heading, and what should we be thinking about when it comes to the big investments over the next 15 to 20 years. So that's probably enough from me. My job's to make sure we get this done on time, field the questions, so make sure you get them in, please, and to challenge our panel sufficiently that they feel as though they've earned their lunch or dinner or breakfast, depending on where you are in the world after this session. So sit back and relax. Right. First up, I'm going to start with Jakob. Jakob, you're busy running plants right now. You and I go back a long way. We've been in this space quite a bit of time. So welcome to the panel. What is going on in your part of the world, and what is the future of EFW, if I use that phrase, or waste to energy, or resource recovery even?
Exactly. I sometimes do sort of the argument that we should use waste to energy rather than energy from waste in terms of what is the main purpose of waste to energy in that sense. But let's come back to that later, maybe. Well, I work at CISAV, which is a municipality-owned company, 14 municipality owners in the southernmost part of Sweden. And we have a plant. We have 4 lines of waste to energy, mainly taking care of the municipalities, their own waste, so to speak, and the inhabitants in those municipalities, but also industrial waste from the region. But yeah, lots of things are going on, I'd say. I mean, the industry is evolving in our part, in that sense that I mean, even though I don't think it's necessarily changing from the hygienic and the sanitary role, being sort of the outlet for waste that has not been prevented or recycled, and that should be destroyed due to, for instance, hazardous properties. That's still the main task, in my opinion, our opinion. But I mean, basically taking care of residual waste, right? But I think what you just said in the introduction, really, there's an evolvement in terms of carbon dioxide, really, mitigating climate change and what comes with that. And that's, I mean, when I go into that, I mean, a bit deeper, I guess, during this session, but let's just put carbon capture out there. And also, how do we incentivize for less residual waste and less fossil content within the residual waste? I think is one of the main tasks going forward as well. It's really short, but I guess we're gonna dig deep, or
Well, I think you've set the scene out nicely. I mean, talk to me a little bit about CSAFE. For
yeah.
those that aren't from Europe, let's say. I mean, how many plants you got? What's your years of operation?
Yeah, we've been in operation. Actually, we have 4 lines, one big plant in Malmö. Malmö is a sort of the third largest city in Sweden, located, I usually say, in the vicinity of Copenhagen, which is in Denmark, but we only had a bridge in between us, so that's why I'm saying that. And I mean, it's a rather big plant, 630,000 tons of waste throughput every year. 4 lines, as I said. The two sort of older lines are from the beginning of the 70s, so 1970s. So they are quite old, and they've been revamped several times the past years. And then we have 2 more lines in the beginning of the 21st century. So really, it's 2 different centuries really of plants, but still very manageable, those plants. And the throughput is quite big, quite a huge number. And what we get out in form of in terms of electricity, but also in terms of heat, which is a main. Yeah, 2 of the lines are all the lines are CHP. Sorry, 2 lines are actually just heat, and the other 2 lines, the new ones, are CHP. So we have both electricity and heat production in those lines. And the district heating network here, we have a different sort of setup that is owned by a private company, E.ON, in Malmö and Burlöv, which is the municipality that also is where we have the district heating system. So throughput to the district heating system, but also electricity production and delivery to the district heating network, the electricity network. So it's quite a big operation in that sense. Also, CSAV is not just waste to energy. We have a lot of different waste handling plants. I mean, one thing that I'm very particularly proud of is actually the textile sorting plant, which is a new one. But we also have IBA sorting plants, stationary, very big one, from the instrumentation bottom ash. We get a lot of metals out. Well, it would be better if the metals weren't in the residual waste in the first place, of course. But since we have that in the residual waste, we can actually get it out in the back end from our IBA sorting plant. We also have composting. We have a pre-treatment plant for food waste going to AD process, anaerobic digestion, making actually upgrading to vehicle gas, and also having the biofertilizers going to agricultural use as well. So it's a big operation. Throughput approximately 1 million tons of waste total, of which then 630,000 goes to waste energy plants.
Thank you, Jakob. And I've been. It's a few years ago, but it's a good site, or site, shall I say, and it's well worth a visit. And I've got to be honest, from a sewage perspective here in the UK, I mean, I think we've got 9 operational sites. We've got combined heat and power at several of those, and I think the heat offtake is a really interesting position. It's definitely for me a better option where you can do it, but of course you need either local network or local users. But going forward, I think we've got carbon capture potentially at 2 of our sites, and that's we're having to rethink everything now to go, well, how do we make sure that the projects now stack up in a way that not only are we managing that residual that couldn't be recycled, didn't have an answer in an anaerobic digestion plant or a composter or whatever it might be, particularly the slightly hazardous, or the nappies and all the other bits and pieces. But then how do you make sure that all the investment in carbon capture then pays for itself? Because it's a business. Yours is a business, mine is a business, and that's, I think, quite an interesting challenge for probably some of the people on this call, given where they're coming from today.
For sure.
The cost of putting EFWs in is not cheap, but then doing all the other technology is a big investment. So I'm sure we'll come back to that. Listen, audience, it's great to know where you're from. Thanks very much. If you've got questions, though, put them in the Q&A, please, because it's easier for me to screen them on the other picture. Right, I'm going to Marco, who is not going to move for the entirety of his presentation, because that picture is a beauty, and it's good to see you, Marco. How are you?
Very good. How are you, Adam? Nice to see you.
I'm all right, mate. Tell me a little bit about what you're up to, who you work for, and where you think this whole technology place is heading.
Well, I mean, who I work for? I work for City College of New York, Chemical Engineering Department. We have a center there. We call it the Earth Engineering Center, but as you introduced us, it's a part of the WTERT kind of global network, and this is the Earth Engineering Center is the WTRT USA division. Um, what are we up to? You can't only work on one part of garbage when it starts, and especially in New York City. So while we have a main focus in thermal conversion, kind of analyses, research, technical due diligences, we touch everything in the waste hierarchy. We've done things from reuse all the way to, looking at activities and events and ways to, properly landfill. We've done a number of different studies that look at, let's call it conventional waste energy facilities in terms of working with them on details of combating corrosion and just looking at advanced types of operations, all the way to smaller technologies that are coming online, if you will, or trying to be vetted out and displayed and demonstrated, where we'll do some analyses, if you will, third-party analyses on them to understand their efficacy and their performance, say, compared to conventional technologies. So focus on thermal conversions for sure, but then move to all facets of the waste hierarchy.
Thank you. And if you were to, if you were an investor, or if you were a big municipality in any region of the world that you want to pick, would you be going, energy from waste, heat off take, carbon capture, or would you be saying, no, the future's chemicals, the future's different manufacturing types? Where's your technology bet going?
Yeah, that's all right. That's a very wide question. I'll have to focus it down and let me kind of touch upon two or three areas. I'll call it the kind of Western Hemisphere, the USA, and then places south, and then I'll maybe touch upon a little bit on what we've seen going on also in Africa. Technology bet in the United States, I would say that conventional waste energy with let's call it materials recovery, and I'll give you an example of that in a second, is kind of where things should go. And there's ups and downs. It's actually not very robust these days, but there is a lot of interest. And I think what distracts a little bit from, call it conventional waste energy, to be invested in and be forwarded, are these up and coming technologies. And I call them up and coming only because they haven't been demonstrated at the 3,000 ton per day and larger scales. But they garner a lot of interest because, as you say, Adam, they report out certain tests that demonstrate that they can maybe produce something other than electricity and heat. And we could get into the details there because the performance is quite uneven and it's actually at a very small scale. Um, but you know, the big problem in the United States is the perception of waste energy. There are about 70 plants operating, any of them from 8 years old over to 35 years old, and if you look at the permits and the regulations and so on, they're performing quite well. And I could give you some details on their contributions to the airshed. If we move to, what I would consider like Mexico and southern South America and southern environments there, our work has really been trying to have a basis and a robust foundation of collection, normal collection that happens all the time. And then there's economic constraints that really prevent let's call it large scale waste energy facilities. And a lot of the things that we've seen in the South American southern environments is that not only is collection very uneven, but the disposal, the landfilling is not quite as modern as it should be. I will say, though, one thing that I'm encouraged about is we have had visitors from Bulgaria, from Africa, from China, from a number of places, that just come to the WTRT USA and the City College and kind of just ask a bunch of questions, send delegations there, and we, I can't say that we were a big part of one success, but one success that I do see is there was a waste energy facility built in Addis Ababa and in Ethiopia, and that's operating. And if you have an area and a location like that could make it work, I think it could be made to work in all types of economic and let's call it developed or developed status. So I stopped there because I know we want to have a conversation, but I hopefully that gives you the perspective you were thinking.
Perfect, Marco. Thanks for that. And you've provoked a bit of discussion, both in the chat and in the Q&A. So we'll come back to that in a moment. But let's well, I'm going to let Demetra speak first, and then I'm going to start throwing some of these questions around because there's some spiky ones in here, which I think will be good use of our time as experts, inverted commas. So Demetra, welcome. How are you?
I'm doing well, and you?
Good. Yeah, I'm well. We've known each other a little while through the ISRA program. So tell me a little bit about what you're up to now.
Right. So my name is Demetra Tsiamis, and I'm a chemical engineer with a background in applied research and sustainable waste management. So I've had the opportunity to work on projects spanning along the waste management hierarchy and worked on several projects related to pyrolysis and gasification of plastic waste in our municipal solid waste streams. So specifically conducting practical technical due diligence of pilot scale and commercial scale technologies in this space. Currently, I'm a senior researcher at the Alliance to End Plastic Waste, where we focus on the transition of the circular economy of plastics. So one thing I do have to just note is that in this webinar, I will be just speaking on behalf of myself. I'm not representing the viewpoints of the Alliance to End Plastic Waste. So all viewpoints, ideas, opinions that are shared are solely my own and not necessarily those of the Alliance.
Thank you for that. I won't push you on why, because I find it very difficult to whenever I speak, I might be here as Adam Reed, but you all know that I work for Suez. It's just, by association, it's difficult, even if you claim that you're speaking independently, but I accept your point. I mean, given what you do currently, though, you've been heavily involved in projects around the world looking at, that some of that upstream intervention, which is where a lot of the questions are coming in, is well, Adam, why are you talking about this stuff at the end of pipe? Why are you talking about, inefficient approaches to managing resources? Why are you burning stuff? I mean, that's kind of the flavor that I'm getting at the moment. So as somebody that's currently actively involved in upstream intervention and projects, I mean, why are we still doing energy from waste to energy, burning, incineration, pick your poison?
Right. So yeah, I think in this discussion, I can speak a lot more to the pyrolysis and gasification aspect of plastic waste. But I think when we're talking about circular economy, yes, you're right. The end goal is for industries to develop products with the end of life of that product in mind. I do believe, though, that transition takes time. And so during that period, while the science and innovation has to come into play to essentially be able to create products that still have the same parameters, whether we're talking about performance capability, purity, aesthetics, all of these things that we need to maintain while also developing circularity inherently within that product, you and I will still be generating waste every single day. There's no such thing as really, I think, a 0 pound per person per day in terms of amount of waste generated. So there's still things that are going into the black bags, into the refuse bin, that really, when we go along the waste management hierarchy, energy recovery is really addressing the things that can't be reused, can't be composted, anaerobically digested, mechanically recycled. So if we're talking about plastics right now, that's currently films, multi-layers, flexibles. So with technologies such as pyrolysis and gasification, I'll speak to pyrolysis specifically, you can take those plastics and convert it to an oil for transportation fuel or as a chemical building block. So kind of offsetting the need for fossil fuels. So I think that the ultimate goal is to get to that circular economy. But the reality of waste generation and dealing with waste as a pollutant, we still have to have these practices in place for a while until we can really get there. And I think that's dictated by both the science of it and also policy.
Okay, thank you. That's really interesting. Now, all three of you, and we'll start with Jakob maybe, but I'll get all three of your perspectives on this, because a lot of the questions are coming in about sort of the current state of play. Where are we with gasification, pyrolysis, other chemical processes, compared to where are we with more traditional energy from waste type technologies? But then the question that then comes is, and we're going to move to carbon capture. How confident are we with the experiences of all of these technologies that have all come to the market relatively late, and although they've been in other sectors doing other things, their performance with residual waste probably hasn't been as perfect as many of us would have liked. So I think the question that a lot of the audience are asking is, are any of these technologies really the answer to a residual waste problem? Start with you, Jakob.
Yeah, I mean, it's a good question, and the question has been around there for quite some while. I mean, in UK, you know all the big plants that were built and didn't really go as planned a few years back. But then again, I think the answer is not that easy either. I would say that we need all the technology available, and I mean residual waste. If we just take the black bin or the residual bin, or that is quite heterogeneous, and there are traditional ways of dealing with that for sure. But then again, if we move to a more circular economy and having a more source separation, better products, better design, material choices, better circular business models, product service systems with ownership going to the producers, having the producers have the ownership and longer lifetime of the product, and so on. I think the residual flow can be more homogenic also. And I think in those cases, there are, of course, a business model or a technical way forward going with these kind of new technology as well. I think that we should have that in mind as well. But for the residual waste flows, I think traditional great fluidized beds still are the best for that waste flows. But bear in mind, I mean, the heterogeneous waste flows will, and I think must change coming years. Maybe not next year, maybe not in 5 years going forward, but maybe in 50 years time. There's going to happen a lot there, I think. So I see a lot of different technologies to treat waste. Not to say, I mean, in Sweden we have 80 processes that is quite. It's there, and we use it so long now, and I mean, in several countries, that's still a question if that's doable. And I say, yeah, that's doable. So, but not for the residual waste that is the sort of the part that goes into black bin. No, for the food waste. So better source separation, better homogenic streams, more different technologies to treat those waste streams. Yeah.
I mean, I think you're absolutely right, Jakob. The idea of the segregated material streams, the more material streams we handle earlier, and again, a lot of the commentary coming in is saying exactly the same. You know, this stuff that's in residual, surely it's recyclable, surely it's something. And the answer is, well, yes, it is. But the point is, it's in the wrong container, the wrong bin, the wrong stream. By the time it gets to the sites, it's very hard to do much with it that's positive. We need to get the interventions earlier to get those clean streams.
And just a comment on that one, because there's some sort of a notion right now that if we just change the word waste to resource, circularity will prosper automatically. And I mean, you have to have real drivers for the recycled material going into new production, for circular design, for ownership, and so on. And I think we cannot just sort of gaze upon the waste sector to create those drivers for circularity. We need to gaze higher upstream, and you've already been onto this as well, Dimitra. And I think that's one of the key aspects of actually going forward.
Thank you for that, Dimitra. So somebody's asking explicitly, can you name You don't have to, but I mean, are there any, I think is the right question, any significantly scaled pyrolysis plants which have been operational and are viable? Is that something that we can put up as a best practice case study that others can look and go, well, we could implement that or not, or we could learn from it? Because I think that's one of the problems with a lot of these technology innovation spaces, and certainly a few people have referenced the UK technology demonstrator program, which was 15, 20 years ago. We started looking at which technologies would replace our traditional approaches, and we put a lot of time and effort into learning about pyrolysis and gasification and pilot plants, and in the end we kind of, most of the evidence was they're a lot of hard work for not a lot of gain. They're really difficult to implement, and actually they probably aren't the answer economically in our marketplace. And so I guess the question for you is, are you seeing positive steps? Have you got plants that you can use as reference points? Are we going to create data that's going to be compelling for others?
Yeah, I think that's a good question. With regards to pyrolysis plants, there are pilot scale operations that we've seen globally that have been operating. Commercial scale, I would say less so. I think that the advantage of these types of technologies is obviously in the fuel flexibility compared to waste to energy. What's great about waste energy is its ability to take in all kinds of waste, a really heterogeneous stream, whereas gasification and pyrolysis are requiring much more refined streams, especially in pyrolysis if we're talking of plastic to oil or plastic to chemical. A lot of the chemical industry is looking to do plastic to chemical because that's pretty much circular, whereas a plastic to transport fuel, not so much. So in terms of the operations, I think the tricky part is, as you mentioned, the high capital costs that are associated with these types of technologies. And also, I think with anything, it's essentially the waste management infrastructure, because you're trying to generate, let's say, a pure product from an unpredictable stream. So it's streamlining that feedstock to get the spec that you need for your product. So we have been looking at technologies around the world to look at their operations. And in terms of gasification, I would say that there are commercial scale gasification processes, less so for syngas to liquid fuels and chemicals, but more so to electricity in Japan. But again, there are so many parameters that help provide that in terms of, the policy support, as well as just the infrastructure that can be combined with it.
And I think you've raised a really important point there, Demetra, that it's very difficult to compare a technology operating in one geography to a technology operating in another, because the material streams are different, seasonality, water content. Then you've got the legislative framework, you've got incentives, you haven't got incentives, you've got taxes, you haven't got taxes, and I think you've also got behaviours. And I think what's interesting here, a lot of the conversation I'm reading now is saying, should we be putting more time and effort into front end sorting versus back end sorting? So pre any burner, some mixed black bag sorting. There's evidence out there that says it works. And I guess a lot of that comes down to what's the costs and what's the benefits, and they will vary from geography to geography based on everything from local pricing to availability of labour, I guess. So nothing's ever easy when it comes to comparing one type to another. So Marco, on that, I mean, I've got a load of people challenging me right now. I mean, I feel like I'm in the middle of a bar brawl, which is kind of quite entertaining for those of you that have ever been in one. Should all of the emphasis be on that upstream activity? Can we get people to sort better? Can we get the system to be more efficient? Can we get the materials to be cleaner? Can we drive simplicity in design, the circular model? Is that where all of our emphasis should go? Or do we need some catch-all technologies at the back end? Because transition takes time. And I think Demetra, made the point, we're just not efficient. Society is not efficient. There's always leakage. So I kind of, if we've only got a certain amount of money to spend and we've only got so much time to, save the planet and society, where are we going to put all this effort?
So, okay, let me answer the question directly right away. We definitely need a catch-all technology. Okay. I'll give some perspective on that. And little bit of a past perspective that might sound what you might consider pessimistic, but then I think there is optimism and hope for the future. Um, so, we've done work, and I'll mention some names of companies that I think, this audience should look into because there are, let's call it pros and cons and so on. We've worked with Enerchem, with Thermoselect, Braven Environmental, a company called Upcycle, Alpha Cat. We've even worked with Covanta, who's now Reworld, that has delved into the let's call it gasification pyrolysis space, and they would bring in waste management with S4 technologies had done that as well. And of course, Jakob and I think Adam, you had touched upon the alt energy aspect there in Tees Valley. These organizations, right, were focused on the upstream sorting, working well, and pulling in a more or less consistent type of stream that they can then process without using excess oxygen, right? Either gasify it or pyrolyze it. Then they needed an offtake. And I'll also touch upon something where, in terms of focusing energies and money on the upstream sorting, might get us there if we did it because those types of technologies work. I'm not so sure about that. And I'll give a very specific, although maybe very local example where we looked at the tracking of the recycling that was done in New York City. We looked at metals, glass, plastic, and paper. And just to give the details on the plastic, in New York City, they actually sort quite well. The citizens there very, attuned to the environment. It's a dense area, and we're able to get the proper plastic into the proper bin. What we tracked was that of those plastics that went into the proper blue bin, only 49% of it actually had an offtake market. And so, even though that stream was there, only about half of it was going to recycle, right? So now you have this other half, and where's that going to go? And we can discuss that. But I do want to get to let's call it more positive aspect of this, right? So you've got, let's call it the citizenry, that there are pockets where the separation is being sorted well. In New York City, they diverted food waste, but that actually didn't go well. Plastic, okay, that seemed to go okay because 50% of at least what was set aside was being recycled or at least given to an offtake market. The other 50%, while we couldn't track it, we suspect large portion of it went back to a landfill or into a landfill, let's say, because it was diverted originally. But we had seen, and this is where the future maybe might be a little bit better. Companies like Agilix, who would have a pure stream of plastics, right, would melt it down, and they just kind of had a crude oil, and they had an offtake market of a Valero refinery that would process it. And so that was kind of in my mind, the beginnings of looking at these types of technologies that said, okay, with the stream that we're getting in, here's what we can do with it, but then let's send it to a processor that can handle that. And why do I think the future is maybe more optimistic than was in the past? Because now you have very large companies like, and I'll again give an example of ones that we work with, because we know the details, but there's others. BASF, right? They need to make chemicals, and they are very interested in getting, of course, all kinds of feedstock, and most of it comes from fossil fuel. But recently, past 4 years or 3 years, they have been actively engaged in taking pyrolysis oils from anywhere, any company, and rolling it into their downstream refining, and particularly with the fluid catalytic crackers, because those types of technologies, the fluid catalytic crackers, could handle, more or less a wider range of the hydrogen to carbon ratio that's needed. And right now that they can handle this kind of, let's call it, nominally fluctuating pyrolysis oil composition to make precursors to plastics, they're actually starting to bring in pyrolysis oils from biomass. So when you combine in my mind, the three legs of, okay, let's get some source separation going. It's not going to all be used. Let's then send it to a technology that will just process that one stream and then yield something that a larger company that knows how to handle at scale that type of, let's call it crude oil that comes off of it. I think there is there's potential for that. But all of that to say, you're not going to get that entire mixed waste stream sorted. So as Jakob had mentioned and others, you got to have the catch-all technology. And if you want to make sure that you recover as much energy and materials, you got to burn it.
Thanks for that, Marco. I mean, you covered a huge amount of scope there, which is great. And I mean, I totally agree. We've worked with many of those companies you've identified as Suez, both here in the UK and globally, because we're fascinated with the long-term, more circular movement of material or molecule, and we don't see the future long-term being about energy, because there's so many other issues being raised on today's call, like carbon capture is inefficient, burning waste is inefficient, it's not a way to generate power or heat. In an ideal world, I get all of that, but you do raise the valuable point that there is a catch-all because society is inefficient. So until we get society into a more efficient space, we're going to have this transition where you still need something that's catch-all. Interestingly, though, and I want to bring Demetra and Jakob in on this one. We're seeing quite an interesting commentary from the audience today, which is great, around if we can segregate organics, it makes the concept of mixed black bag sorting, the residual waste sorting, a much more viable option, because here in the UK, historically, that kind of sorting of rubbish has always kind of been a bit of a failed kind of business opportunity, because the quality of the material is poor and also the conditions of the sorting are harsh. But if a lot of that organics goes, because we get more source segregation, we get more of that curbside collections and community composting and everything else that comes with targeting organic collections, then does that mean that suddenly a technology that in the UK we've struggled to benefit from might actually work better, as it does in Italy, for example? And we've got the case of Milan being shown, where high segregation of organics means the mixed waste sorting at the back end is nowhere near the same experience as it is, say, in the UK currently. I mean, I don't know, Jakob, if you've had a look at mixed bag sorting.
Well, just to give a brief, yeah, I agree in that sense that if the more we source separate, segregate upfront or at source separation level, the better use for those flows is of course a result. And I think that you said a UK example, the MPTs, the MRFs, they were in the beginning basically sort of there to make a fuel, really, to be harsh, which was not maybe the best solution going forward. And I think also, but I mean, if we did have more source separation of the organics in the UK at that time, I don't think the plastics would have been recycled in a much higher sense at that time. But then again, now it could be, yeah. So I think that there's a change, but also the change, and Marco, you were on it, and Dimitri as well. The change is a driver from those industries, the chemical industry, the plastic producers. They are asking for material to have that waste to resource sort of approach, and that's the driver, and that's the driver that we need to have those sort of after. I call them after separation because it's after source separation. I don't call them pre-separation before incineration. I think it's a good thing to say after separation, after source separation. So a next stage of separation. We don't do that much in Sweden, I'd say. We have organic source separation in the main part of the municipalities in Sweden. So we have the food waste segregated from the residual waste, but still there's not much of after separation going on. Some municipalities have it. Stockholm, for instance, have it. But then again, we're back to what's the best fit for each region, city. Stockholm is an interesting city because of you can compare it to London in a sense, because there's a shortage of sort of area and to have the source separation. Then it's easier to collect everything in one bin after some source separation, and then have the after separation process more mechanically. Yeah, that makes sense, for instance, but that wouldn't make sense in, for instance, a rural area in where we are operating in southern part of Sweden, because we have the space for source separation at place, and that's always the best place to do it, I think. Yeah.
No, you raised some really valid points, and I think, you know, every place is slightly different, and yet we've got some real principles here that I think a lot of the audience are signing up to in terms of the things we should be doing and shouldn't be doing. And I mean, you know, Demetra, I mean, the word, I've used the word transition technology, and I've upset a few people already. So you know, I'll hold my hands up. I quite like the term, but if we've got infrastructure now, there's always going to be a need to run it down over time to its natural end of conclusion, let's say whatever its operating lifetime was meant to be, or the cost model was set up for. As you build other solutions, more circular solutions, more segregated solutions, you know, solutions that are a step 3, 4 above that operation. I don't think I'm challenging that thought at all. But I guess how easy is it to do that when, you know, there's an economic model and there's a contract in place, and you know, change involves lots of moving pieces, and therefore that could be quite complicated. I mean, I think if we were building infrastructure out today, both Jakob and I and Marco have all suggested that we would be building out slightly different things than we were building out 10 years ago, because markets have changed, demand has changed. There's a demand for aviation fuel, there's a demand for the chemicals, for manufacturing. So we're being impacted by different economic drivers and market demands and customer demands right now. But I guess that doesn't get over the fact that I might be 15 years into a 25-year you know, contract for a plant that was designed to operate for 25 years. So I mean, is that something you're seeing? Is that something that's worrying you?
Yeah, I mean, I think you hit the nail on the head about everything that is waste management, is that it's so complex. It has so many parameters that affect it. And I think that just to kind of talk about the infrastructure that we just talked about before, that really to have these technologies be relevant and do their part is really getting those refined streams to them as easily as possible. But that statement is difficult because it involves so many different players, the municipalities that are involved, the economics that are involved. So, I mean, just one point I wanted to make regarding the infrastructure that you were talking about is, you know, I come from New York City, and I always just wish that there was besides our dual stream recycling, that we just had a separate stream that was collecting the non-recyclable plastics, which are the films, multi-layers, and flexibles, and that could have a direct line to these types of technologies that can capture the energy from it, or in the case of pyrolysis and gasification, because that is really what you need to have these technologies operational, and also to have these technologies have guaranteed offtake, because you want less variability in what's coming into them. So I think in terms of how long, I guess your question is around kind of the lifetime of the infrastructure that we put into place, and will it become kind of irrelevant over time as we become more and more circular. I think we have to be realistic about the volumes that we're dealing with. So I'm just going to throw a statistic out there, which is from UNEP's Global Outlook 2024. By 2050, they estimated 56% increase in our global MSW generation, which is in the order of billions of tons. And so our current infrastructures today really can't handle that waste, and we're seeing that. And I think that there will always be a shift in these technologies, that having pyrolysis and gasification and waste to energy is not wanting to continuously have waste. I think that there is always room for shift as we become more circular. There's going to be a shift in the knowledge and know-how of these companies and of these technologies that will then be needed for a new area that we haven't even thought of yet, if that makes any sense. So I don't know if I fully addressed your question around the lifetime of these things, but
well, I don't think there's a right and wrong. I think you know, we're both talking about transition, and transition takes time and effort, and it isn't always the same speed of change or efficiency of change. Hence why some of us, are buy into the transition kind of approach, and others would want a more catastrophic start-stop approach. I think it's interesting. There's some really good conversations now cropping up about somebody likes Addis Ababa plant, somebody doesn't. I think it's fascinating, listening from different perspectives and geographies about food waste segregation working or not working. I think read the chat, those of you that haven't been contributing, have a look at it. It's some fantastic stuff. I've got some points here. My mentor many years ago, Professor David Wilson's on the line. Hello, David. Hope you're well. And he's dropped in a little bit of commentary here about the role of waste to energy in developing economies, and sort of those countries that are on the call today, who are probably looking at this going, well, look, the West have been doing it for 50 years. The technology's improved. The emissions are dropping all the time. We'll have a slice of that because we don't want these dump sites anymore, and we haven't got the land for whatever it might be. But he makes a really valid point that there are preconditions that you need before you can ever consider a technology like energy for waste. So if you're one of those people that's going, do I need an Addis Ababa solution or not? I think you've got to make sure that you've got decent collection system in place. You've got decent controlled disposal in place. You've got an economic model that's going to be able to pay for it long term, whether that be taxation or user fees or whatever it might be. So those kinds of preconditions of affordability and availability and suitability are really, really important. And there's some good reports out there, UNEP, GIZ and others that have looked at this historically. So check those out if you're in that kind of position thinking, oh, it's the West, it works, we'll have a slice. Make sure that you have a good look at, the experiences of other countries that maybe mirror your composition or your economic model more closely than perhaps London or Malmo. Jakob, you want to come in?
Yeah, first of all, I totally agree with David there. That's a very, very valid point. In terms of the sort of the stranded assets aspect, I think there's a notion of the waste treatment plant affecting what waste is generated, and that I think is a wrong sort of thinking, because a waste incineration plant doesn't mean that there will be more residual waste. The waste incineration plant is there to handle what is being generated. So if you build a waste incineration plant and there's no residual waste left, then you have a stranded asset, and that's your bad planning, and that's fine, and that's for you to take care of, and that's a bad planning. But the notion of having that incineration plant actually being the cause of generating waste, that's a wrong notion. We need to think of the chronological here. The waste isn't generated because we have a waste to energy plant. The waste is generated because upstream activities. So have that in mind always, I think.
That's a very, very valid point. Just a quick word on the chat. Let's be careful with some of the language. We don't want to offend each other. Right, let's crack on. Marco, let's get you back into this loop, mate. I mean, lots of technologies, lots of material streams, lots of demands to go earlier, lots of more interventions, probably more costs. At the moment, I'm not sure who's funding all of this. So I guess the question is, if we're going to transition away from energy from waste, if we're not going to sink millions into carbon capture with its uncertainty, then, who's going to fund the transition to go more circular, less impact, more sorting, more pre-sorting, more reuse, more repair, things that I like talking about? Where, I mean, consumers aren't going to foot the bill, are they? Surely.
Well, yeah, I mean, this is the major question, right? I mean, you've got municipalities. I mean, my gosh, I go all the way back to 2004 and 5 when St. Lucie County in Florida wanted to install a gasifier, a plasma pyrolysis system instead of a conventional waste energy facility, and the municipality spent all kinds of money, and when it did not come to fruition, they were out of money. So they, so one always asks, if they just went ahead with a conventional technology, they would have had the money to do it, and they would have been processing the garbage. But now that this, technology didn't go forward, they're left with still nothing. Who's going to fund it? Well, it's going to be a combination. Okay, it's going to be a combination of, as Jakob said, hit the nail on the head. Right, the waste energy facility is not built and then starts creating waste. The waste gets created, and then the facility gets built to manage that. Now, so there's, let's call that the consumer, the citizen, the taxpayer, whatever you want it is. There's a portion of that. And that goes into municipality to responsibly manage the money, to responsibly process the waste. And in the United States, and especially in New York City, they like to just send maybe 60% of that waste over to other states and counties, and then they consider that managing it. And okay, that's what they do, and they pay $120 a ton to do that. Yet they could pay less if they just sent it across the river into New Jersey to a waste energy facility or over to Hempstead, Long Island. Another aspect that could be paid, and again, we've kind of touched upon this, energy, at least in the United States, right? Very, very inexpensive. So that is not the solution. There are some places that get 1 cent per kilowatt hour that's generated. So that's not going to do it. Things are spaced quite far, and so district heating doesn't quite work in the U.S. However, it's materials recovery. You've got the materials recovery going on quite well. One thing I'll say that's, I think, again, maybe encouraging in the future is there is a focus on critical materials and rare earth elements. And, analyses that we've done show that if you recover those types of critical materials and rare earth elements, which unlike precious metals, while they still have a very good spot price for them, unlike precious metals, there is a much higher demand in terms of many more consumer products for them. Of course, gold and silver we could talk about, but you look at things like manganese, you look at things like cobalt, you look at things like yttrium and lithium. Recovering, let's just say, anywhere between 20% and 50% of those elements from the garbage waste ash stream after it goes through an incineration or waste energy facility and it's got the back end conversion on it to get those. In the US, we could offset somewhere between 100% to about 25% of the imports from those rare earth elements and critical materials. So that is what I would consider, a market driver for that, right? Because if you're offsetting those imports, now, you could affect that economy. So I think it's going to be a combination. It has to be from the municipality to the commercial sector.
Thank you. Thank you. Right. I've got one more technical question, and then I'm going to let my speakers do a little roundup from their perspectives. But the questions, we've talked about carbon emissions. We've talked about, combustion efficiency and all the other negatives about why these technologies shouldn't have a long-term future. So, but the one that's popped up at the end here about fly ash and toxic solid residue. So, Jakob, you're running the plant right now, so I'm going to direct that one straight at you.
Thank you.
I mean, that's all right, because I'm sure you've got some evidence. But is it the big problem that some people would argue, or is it under control?
But just to sort of have a different approach here to it. I mean, the fly ash doesn't it's not created. It's there already. It's in the waste. The toxics are there in the waste already. Of course, you have a different kind of setup of chemicals in the fly ash than you had in the waste to begin with, and sometimes it's a little bit more hazardous, and that's why it's so important that hazardous waste is actually collected and being taken care of in a good way. For instance, we have the same with landfilling. Some of the landfilling in cells of, for instance, asbestos. It's critical that we landfill asbestos. We don't want to have that in the technosphere, in the new materials. It's the same with fly ash. We need to take care of that in a sound way, environmentally and socially, and sound way. So that's what we do. But that being said, I'm all for having less waste to incineration. Yes, of course, and then you will have less fly ash. But that doesn't, you can't really sort of deal with that when it's already generated. We need to deal with that upstream. So that's what I'm saying. But prevention, yes, prevent more. We need to prevent more. And what we as an industry need to do more, I think, is give better feedback upstream. What is bad and what is good in terms of what comes to us. I think that's a really, really good improvement point for the waste sector to actually put that information upstream in a better way.
I think that's a really important point to almost end on, because you're right. It's being able to share that intelligence.
Yes.
We've got solid recover fuel plants that are producing a coal substitute for cement kilns. And one of the key pieces of feedback is about the PVC levels, because the chlorine content really affects the process and gives them a real headache. So actually us talking to our customers about the materials coming into our plant and saying, well, that isn't helping because it causes a problem for our customer. That's the supply chain starting to work out where the toxin, where the problem, where the issues lie. And I think that's a really important lesson to be learned. So thank you for that. Right, listen, I'm conscious of time. I want to give a shout out. David Wilson, thank you. Peter Barzik, thank you. Dr. John Webb, thank you. I'm going to give a shout out to Neil Pitcairn, thank you. There's some brilliant chat being going on, and I appreciate we're not all on the same page and we don't agree on everything, but that's important, because at the moment, I think that's why this is such an important topic. More investment, less investment, new technology, old technology, and the conversation about the combustion engine and now electric vehicles, I think is a great analogy of how this sector is transforming because of demands at both ends of the equation. So thank you for that. Listen, I'm into the last couple of minutes, so give me a roundup. What's your takeaway message? One message, Marco.
One message is that recycling is not going to handle it. We've demonstrated and calculated that you can only probably get to a certain level. It's been stagnant in the United States for the last 20, 30 years. And therefore, if you're going to continue with mixed waste, you need a catch-all technology. Doesn't mean that the others shouldn't be explored and developed, but you still have to have that catch-all.
Good takeaway message. Jakob.
I couldn't agree more with Marco. I mean, there is a need for different kinds of technologies, and we must put our effort upstream. We must put our effort in the materials we choose for products, in design, in circular economy business models. That's the key. But then again, waste is being generated, and that needs to be dealt with. So I agree with Marco, but still, our sector can do more in terms of feedback upstream. That's my sort of last words. Feedback upstream from the waste sector is a key.
Okay, and last word to Demetra.
So I would say there just needs to be synergy between industry, between the consumer, and between the waste remediation. So having policies such as extended producer responsibility, having consumer public education on waste generation, and then having these technologies that are really capturing that value from waste. They're all needed as we progress towards that circular economy end goal.
Thank you. So I'm going to summarize with, I like to finish with a hashtag that I can print on a reused t-shirt. So it's hashtag catch-all, hashtag upstream feedback, hashtag synergies. And I think I'm going with hashtag Andy Rees, residual waste systemic failure, which I quite like. So I'll give Andy Rees a shout out because he's a frequent flyer on these calls. Listen, I think the feedback you're giving us is great. This is part of a conversation. Be Waste Wise, platform for conversation. Really important that we recognise that not all technologies will work in one location over another. Not all locations are the same. Not all feedstocks are the same. And I can guarantee the economic model and the incentives will not be the same. What we need to guarantee is we're protecting the planet and protecting the communities. And I hope we're all on that journey together. So thank you very much. It's been my pleasure to host you. You've been great with your chat, and panelists, you've been great in taking some flack and answering some difficult questions. So thank you very much. Shweta, the floor is yours.
Thank you, Adam. Thank you, Jakob. Thank you, Demetra. And thank you, Marco. I think Adam pretty much summarized it really well. So thanks a lot for taking all the questions. We've had quite a heated discussion, both on Q&A as well as on chat. So thanks all. And just the audience who wants to know if this is going to be recorded, yes. And it's going to be available on wastewise.be website. You can check it out in a couple of weeks. Bye-bye.
Cheers, everyone.
Yeah, great job, Adam. Thank you.
Take care.
Bye-bye, everyone.